Hello everyone, welcome back. Here is vnAmsen, and today we have another coding problem. Today we are tackling medium difficulty problem from LeetCode titled single number 2. So as you can see, the problem statement says, given an integer array nums where every element appears 3 times except for one, which appears exactly once. Find the single element and return it. And there is an additional constraint. Our solution must have a linear runtime complexity and use only constant extra space. So let's take a look at the code to solve this problem. So we have a class solution, and within it a function single number, which take a list of integer nums and return an integer. So we initialize two variable, one time and two time, and set them to 0. So let's implement it. So first, let's do one time 0 and two time 0 as well. So then for num in nums, what we do, the bit which have appeared for the first time will become one time. So we will do bitwise operation. So one time will be one time num and not two time. So then the bit which have appeared twice before are appearing will become two time. So now we will use bit operation. So two time will be two time num and not one time. So we have one time and also two time, and the remaining bit in one time represent the number appearing once. So finally we return one time. So now let me explain it, or we can run it to see if it's working. So for example, for array with 2, 2, 3, 2, we need to output 3 because it's appearing only once. So what is the logic? So this loop iterates through every number in our list, and we use a bitwise operation to solve this problem, which might seem a bit unusual, but there is actual very efficient for this type of task. So if we point to the one time, we set one time to be the XOR of one time and num, and with the bitwise not of the two times. So this will help us identify the bits which have appeared for the first time only. And then in our two times, what we do, similarly, we update two times to be the XOR, so exclusive OR, of two time and the num, and with bit not of one time. So this captures the bits which have appeared twice before and are appearing now. So it's a third time, yeah. So this bitwise operation might seem a bit confusing at first, but they are very useful for this problem, and XOR operation give us the bits that are different. AND operation give us the bits that are exactly the same, and the NOT operation flipped the bit. So we essentially identifying and isolating the unique numbers from the others. So finally, the remaining bits after this all transformation should be one time, representing the number that appears only once in the list, and that's our answer. So let's run it and put our code to test to see how efficient it is. So yeah, as you can see, the code is quite efficient, and we beat 54% with runtime and also 78% with respect to memory. I think I previously ran it and it even beat 98% with respect to runtime and 78 with respect to memory. So as you can see, our code correctly identified the single element for these test cases. And that's it. This problem might seem daunting at first, especially with the bitwise operation, but once you get the hang of it, it's really interesting and efficient approach. And if you like this video, don't forget to hit the like button and subscribe to the channel, and feel free to drop any question or suggestion in the comments section below. This was vnAmsen. As usual, happy coding, stay motivated. See you next time.